Hey everyone, so now I'm just gonna quickly go over all these number representation questions. So the first one, we want the decimal number 7. So again, use a short division, divided by 2 equals to 3, remainder is 1. Divided by 2 again, equals to, 1, and remainder is 1. And we got to 1, so we read it from upside down, and it gives us 1, 1, 1. And since it is a 4-bit number, we need a padding 0 here. So it is 0, 1, 1, 1. And then we want to change from binary to decimal. All right? And remember, this is used to represent a signed integer. So we need to think of what does it mean for to be a 2's complement binary number. So to change from 2's complement to a the normal binary number, what we're gonna do is we're gonna flip all the sign. And then this will give us a positive number. Flip all the bytes. Positive number. And then we add 1 to it. All right? So what I mean? So for 1, 0, 0, 0, we first flip everything, so it's 0, 1, 1, 1, and we know this is 7. And then we add 1 on there, so 7 add 1 is 8, and we know that this number is 8. However, since it is a 2's complement, so what we are actually representing is -8. All right? And just to rephrase it really quick, so this is -8 because the first bit is 1. And this first bit is not used as what we said before in signed bit. It's rather the result of a 2's complement. So that's why we know this is definitely a negative number. All right. For the second part, for the next part, we have 3 plus 7. So we know 7 is 0, 1, 1, 1. And we know that 3 is 0, 0, 1, 1. If you do a little bit algebra or like the short division, we're gonna have 0. So 1 plus 1 is 0, but it's binary, so it's 0 and we carry 1. And this is 3, so it's equals to 1, we carry 1. And then it's equal to 2, so we carry 1. And the final result is 1, 0, 1, 0. So in the binary form, it is 1, 0, 1, 0. Now, what is the decimal representation? So we know that 3 plus 7 should be 10, but is it? So if you look at this, we first find out that the first bit is 1, so it is a negative number. And to find a negative number in 2's complement binary form, we're gonna flip everything. So 0, 1, 0, 1, which is 3. Which is 5. And then we plus 1, which gives us 6. And we add a minus sign on there. So in binary form, this will just be -6. And we find it is not correct, or it's not something we want. And the reason this is happening is because we are using a 4-bit number only. It is causing a overflow. So as you may already meet in your Java project, if you use an integer, for example, and you store in a really large number to this integer variable, you will get an overflow and it will become negative. And this is the reason. All right? So for the next part, we have 1 left shift by 2. So we have 1. The representation is just 0, 0, 0, 1. And left shift by 2 is I take this whole number, shift by 2. So 0, 0, 0, 1. And I add the padding zeros. So this is 0, 0. And I get rid of the zeros that is like existing, that is more than what I'm using, which is 4-bit. So as a result, this will become 0, 1, 0, 0, which is 4. So this will be 0, 1, 0, 0, and the decimal number is 4. However, if we take a look at the second one, just before we take a look at the second one, just a general rule, if you do not exceed or if you do not overflow your number representation, a left shift is the same as times. So a number, let's say x, left shift by n is the same as x times 2 to the n. All right. And if you do x, that is right shift by n, is the same as x divided by 2 to the n. And remember, this will be an integer. So, or it will be round down. As you see in Java divisions. All right. This is in the case that if there is no overflow. All right. So what if there is? So our last question is 3, which is 0, 0, 1, 1. And left shift by 2, so by the same thing, 0, 0, 1, 1, we pad zeros. We get rid of the extra zeros. And so the binary form is just 1, 1, 0, 0. And what is this? So as we see again, the leading bit is 1. So this is a negative number. And what is it? So to find this number, we're going to flip everything. So 0, 0, 1, 1. We're going to add 1 on there. So first 0, 0, 1, 1, this will give us 3. We're going to add 1 on there, which gives us 4. And it's negative. So this will give us negative 4, which is not what we expected. That is 3 times 4 equals to 12. And the reason is, again, you overflow the integer. And that's all for this section. Thank you all for watching, and see you next time.